So as we know, this log function has to be applied only to positive numbers. This quantity has to be positive. This quantity has to be positive. I think we did this problem sometime a week ago or so. And this has to be greater than 0. 1 over x will be positive only if the denominator is positive, because if this is positive, this has to be positive. So when I solve these three, I realize that this is greater than 1, this is greater than -3, and this is greater than 0. This one will solve all three. So if you want, let's graph it to see what's happening here. So the first one says from 1 to infinity. The next one says from -3 to infinity. And the last one says from 0 to infinity. So all three colors are only here, from 1 to infinity. So the common domain, 1 to infinity. Whatever I get, if I don't get it between 1 and infinity, I will disregard it. Only now I can condense, because there is a difference here. When I condense, I have log base 2 of x minus 1 over x plus 3. And the other side is log base 2 of 1 over x. Two logs are equal and they have the same base. Their expressions have to be the same. This must equal this. There is no other way. Two logs are equal and they have the same base. That means that their expressions have to be the same. The expressions we apply log to. So x minus 1 over x plus 3 must equal 1 over x. Well, this is a proportion. In a proportion, we cross multiply. So we have x squared minus x equals x plus 3. Or x squared, I move everything to one side because this is quadratic now. See what happens from a log to a proportion, to a rational equation, to a quadratic equation. So minus 2x and minus 3 equals 0, x minus 3 and x plus 1. And we get two options, 3 and -1. I don't need to go back and check. I know that this does not fit here. I don't have to go back. This is the only solution. Yes. Very good question. Anything else?
I'm trying to find which number it was. Can we do number 14?
From the same test?
Yes.
Very good. 9, 10, 11, 12, 13, 14. Okay, you write the first four terms. Very good. Is that the one?
Yeah.
So A1 is given to us, A sub 1 is given, A sub n is given to us in the form of a relationship. Of course, for n greater than or equal to 2. I'm already given A1. I have to determine A2. A2 is 4 times A1 plus 2. 4 times 2 is 8. 8 plus 2 is 10. A3 would be 4 times A2 plus 2. 42. And last one, A4, would be 4 times A3 plus 2. So this is 168 plus 2, 170. Very good. Next question.
Maybe number 15.
I'm not sure I heard correctly. Did you say 13?
15.
15. Very good. Yes. So here's 15, n plus 3 factorial divided by n factorial. So I see that the top is bigger, and I try to expand this. I always have to start with the first factor is the starting point that I see here. The next one I subtract 1 from here. The next one I subtract 1 from here. And the next one I subtract 1 from here, but it's n factorial, so I'll stop because I see the denominator is n factorial. 1, 1. So then you can distribute or just leave it alone. So I'm going to distribute here, and I get n squared plus 3n plus 2. And then I'll continue distributing n cubed plus 3n squared plus 2n plus 3n squared plus 9n squared plus 6, and then combine like terms. N cubed is n cubed. Then I have 3 terms with n squared. 15. And then I have 1 term with n, and the last one with no n. Next question, anything?
I have a question on number 17. It says evaluate with the calculator, like the 40. I forget how to say that. But I don't know how to like put it into my calculator.
So we're talking about,
Number 17.
yes, so 40 factorial over 45 factorial. Do I see that correctly?
Yeah.
Very good. So first of all, the numbers are extremely big. I see that the smallest is 40, so I'm going to leave it alone. And then 45 factorial is 45. I always start with what I have here and subtract 1 and subtract 1 and subtract 1 and subtract 1 and subtract 1, but I stop because I can simplify. So this will be an extremely small number. So 1 divided by, in parentheses, 45 times 44 times 43 times 42 times 41. Close the parenthesis and press enter. 6.820766889 times 10 to negative 9. Now, I don't know if the calculator, we can try, if the calculator will be able to calculate this. Maybe, maybe not. So let's do this without simplifying it, like from here. So we write 40, we go to math, we go to probabilities, and we choose the symbol 4. The exclamation mark, which stands for the factorial. And divide by, we write 45. I don't know if it wants parentheses, so I'm going to put parentheses 45 and then factorial. So I go to math, go to probabilities, choose 4, and close the parenthesis. It may give us this, I don't know, or it may say error. if we calculate 45 and we put factorial on it, I doubt that it can calculate this. Okay, it can. 1.19 times 10 to the 56th power. But at some point in time, the memory is too small of the calculator to compute something like this. I don't think. See, 450 factorial, it cannot. It's overflow. It doesn't have that much power. So it's always good to learn how to simplify the factorials because you may not be able to come up with a number. Very good. Is this okay? Is the calculator okay? Everything okay?
Yeah, I don't know what I was thinking.
Don't worry about it. It's, you know, I like to simplify. You already know my keywords, simplify and factor. Because I always think that I can, once I know how to simplify, then maybe the mistakes will be minimized. I don't know. Okay, next question.
We'll do number 4.
Number 4 from the same?
Yes.
Okay. Number 654. Okay, so we have an exponential function. Percentage of information that a particular person remembers. Okay, so that's our function. And I'm on page 6. So f of x equals 80 e to negative 0.5x and plus 20. Find the percentage of information at the moment it was learned. So we already know that this is f of 0. Then f of 1. Then f of 2. No, not 2. We need 4. And f of 52. And then in part B, I think there is a part B. After how many weeks will the percentage drop to 30%? Okay, so the last question is when 30 equals 80 e to negative 0.5x plus 20. The first four items are just very clear. We have to go back to y equals 80 e to, in parentheses, negative 0.5x, close the parenthesis, come down from the power, plus 20. Let me know when we have this. And then we go to second table, and I plug in all these numbers, 0, 1, 4, and 52. I just copy the numbers. 100%, 69%, 31%, and 20%. And they want us to know, to find exactly when f of x is 30%. Okay, that's fine. So first we have to subtract 20. Then we have to divide by 80. And what do we do now? Any suggestions? Anyone has any idea what we need to do next? In order to bring down the power.
Multiply both sides by ln.
Yes, apply natural log to both sides. Awesome. So natural log of 1 over 8 equals negative 0.5x. Because natural log e is 1. So x equals natural log of 1 over 8 over negative 0.5. Good, so in the calculator, so natural log 1 divided by 8, close the parenthesis, divide by in parentheses, don't forget parentheses around the denominator, negative 0.5. So 4.2, roughly 4.2 weeks. Any questions on this? Any questions?